Hi, welcome back. So in this video, we're going to go ahead and start out with accessing structure members. When we want to make use of these structs that we've created, we're going to set them up as a variable. Once we've done that, we can then use the dot operator to access the members. So here is the variable name that we've set up, along with the dot pointer, and then the member or the variable we would like to make use of that's in the struct. Now, with that being said, right now we can see already that we've got student ID and we've got GPA here in this little sample code. If we go up just a couple of slides, we can see that the struct has student ID, it's got name in it, year in school, and GPA. Let's go back to where we were. Here you go. Student ID and GPA. So member variables can be used in any manner appropriate for their data type. Well, now we've got a little bit of a code example. Let's see if we can figure some things out. So here is our struct. The important piece is that we end it with that bracket and the semicolon. And then we've set up a bunch of member variables inside of our struct. Now, once we've done that, once we've made use of the struct, we can use all of these items. Kind of like it's setting up a nice little, if you want to think of it like a box that we're putting all this stuff in. And we can then make copies of this box and continue to put these items into that box. So here, now remember the struct name is payroll. So here we are setting up a struct. An employee is now our variable name. So if we want to make use of any of these items inside of the copy known as employee, then we're going to use this dot operator. So employee, which is the variable name, and we want to make use of employee number, which is right there. If we go to the next page, we can see this continue. Here we've got another dot pointer, another one here, another one here. And then we can also make use of getting that information back. And in this case, now we're going to use what was stored in those variables as part of the information we're going to display. So that's how that program works. It gives a really good example of how to use a struct. And this is just the output from that program. This slide really goes into detail. Really wants you to understand that you can't use bill. So let's say we have a struct and we create a new version of the struct and we call it bill. Bill's the variable. We can't just see out bill because bill has got all those member variables in it. We can do this, which is bill.struct ID, and we can do bill.name and bill.year in school and bill.GPA. So whatever variable name we decide to call this, great. Just make sure you use the dot to get to the actual member variables that are stored in that object, in that struct. Okay. So when it comes to comparing structs, you cannot use a simple equals equals. So this right here will not work. In fact, we should make a circle, put a line through it, right? It just won't work. It will not work. Instead, you have to compare the fields based on their own. So does Bill's version of student ID match William's version of student ID? And again, remember that dot operator. We got to keep using that dot operator. So do these match up? This won't work, but this does work. Now, as you can imagine, if you wanted to, you could write code that would take, if you wanted to compare two structs that are of the same type, then you could write a quick function that would take in two structs. Internally, that function would then compare all the pieces and then return back whether it's the same or not. Okay, in 11.4, we kind of are going backwards a little bit on this. Typically, we would talk about initializing a struct from the very beginning, so that way we can make use of it. In fact, we've already initialized a struct. This right here is initializing the struct. That's okay. We're going to go ahead and follow along with the slides. So initializing a struct. A struct variable can be initialized when defined. And again, what's neat about this is we're actually going to not only create a struct, but we're going to define it with the data that we want in it. Interesting thing, and you're going to see this on the next slide, it has to be in order of the member variables. So what does that mean? So we go back up here to slide 7, student ID, name, year in school, then GPA. That's going to be student ID, name, years in school, GPA. You can also initialize members by member after the definition. So if you wanted, you could do as we've already done, create this variable. Let me add to this, right? So we would say student dot semicolon, and we would get rid of the rest of this. And then we use this to store data right into our student. Now, you can initialize data in order, and you can initialize some of the members, but here's the deal on this. You can only initialize in order. So if you wanted to initialize the person's name and that's it, there's no way to do that because the name is the second parameter in, or the second member variable in the struct, so it has to be the second param. So you can't skip params. So you could go and do like they did where we're initializing Bill with ID 14579, but not doing anything else. And you can't skip ID. So as you can see, they're skipping the number of years. That's illegal. So with this, kind of think about that. And this is probably one of the reasons why this really isn't used all that often in real world. First off, it's hard to read and maintain code because as you're reading code, you don't typically, let's say, pay attention to what the details of a struct are, because down in the code as it's being used, you expect it's going to make sense as you're reading it. This is hard to make sense because when you see this, unless you're intimate with the knowledge of what the student struct looks like, you might just assume that there's only one variable in it that needs to be filled. So that's why this isn't done that common, but you can. That's the point, that you can do that. So in this case, if we wanted to do the student name, excuse me, the number and the name, then we would say student S, the number, and the name, and then close our bracket. If you wanted to do the ID, name, and years in school, I believe it was, then you could do that because those three are in order. You just can't skip fields. I know that sounds, crazy a little bit, and you're going, well, Professor Waits, why would we do this? What's the point of this? The point really is, if you're going to do that in most organizations, you're going to use the full definition. You're going to just go ahead and declare everything all in one fell swoop. This is what makes sense. When you start getting into where you're only initializing one of the variables or a couple of the variables, not all of them, it tends to get a little messy and just doesn't get really used all that often. Here's an example of setting up in the employee pay, please note that this code is kind of just sitting out there as global variables, and that's fine. So these are being stored in the name. This is being stored in the employee number, and this is being stored in the pay rate. But like I said, at this point, there's no more data, so hours and gross pay will be left without being initialized. That's okay. You can do that. It just doesn't really happen all that often. So kind of keep that in mind. So what about if you wanted to have an array of structures? You're in luck, because we can do that. Structures can be defined in arrays. They can be used in place of parallel arrays. And individual structures accessed through subscript notation. Fields within structures accessible using dot notation. So with that being said, to be frank with you, the need for the index, you're used to that. You've worked with arrays. That's this norm. You're used to that. What is a little bit different is the fact that you still have to use the dot operator. So let's say you have an array of 5 students. That array is going to be just like all of the other arrays we've created, which is it's going to be in order in memory. So there's our 4th object, and there's 5th object. What happens is the system, as it's making these, goes, okay, we know that there is a certain number of variables. There's maybe, let's just say there's 4 ints in this struct. That means this space needs to be the size for this struct of 4 times the size of an int. And that means the start of the next struct will be 4 times an int down the path, down in memory, and so forth and so on. That's why it works. And that's why you first have to tell me what one of these do you want to use. So in this case, it's the 5th one. So that means, by the way, I'm just going to draw it in red. Here's 0, 1, 2, 3, 4, 5. So we're going to work with this one. And remember, this one has all of its own member variables. So that's why now we're using the dot. And we're saying, give me that one student ID. Like normal, we've got a little bit of an example here. So here is our struct. As we know, we finish it correctly. And this one has an int. What's the size of an int? And what's the size of a double? So this struct is 1 times int plus 1 times a double. That's the size of this struct. So, with that being said, we have this notion that we're going to, because we can tell just from the very beginning, we're setting up 3 of them, right? So we make a constant, then we go ahead, and here we are setting up pay info workers. So that's the type, that's the variable name, and we're saying how many we want, which happens to come back to this constant of 3. So now we go on to the next page of the code, and we can sit in a for loop just like we would normally do, and we can go and work on each one of these items because we have an index now that we can use. And we can loop through no matter how many items are in this array and do the pieces. Now, what's nice is, again, because you need to indicate what index you want, you can still use a variable, but then you have that dot, which is right there, and then the member function, or excuse me, the member variable you want to make use of. And this is the output. All right. Now, when we come back in the next video, we're going to talk about nested structures. This is where it starts getting a little hairy. This is where we have structures within structures. So I'll see you back here in a little bit when you're ready to go, and we'll jump into that.